Hello, this is Thomas with GN Technologies. This video is a demo of our new GNURadio-REDHAWK integration package that we recently shared at the GRCon 2017 GNU Radio convention that was held in San Diego. There we gave a brief technical overview of the package. A much more detailed overview and this example is available at our website using the link in the video description. Before I go any further, I want to start by giving a special thanks to Drew Cormier for helping put together the initial concept, as well as one of our interns, Chris Conover, who wrote the flow graph to component converter. Without their kickstart, this could not have come together. The extra short version of our briefing is that the integration package provides two main things. First, a pair of GNU radio blocks that act as our REDHAWK ports for getting bulk I/O data into and out of the flow graph, along with the SRI and timestamp included, as stream tags. Second, a conversion tool that reads the flow graph's GRC file and generates a REDHAWK component that wraps the flow graph, mapping used variables to properties and ports to, ports. We also provide a full development capability as well as an extension to the REDHAWK general purpose processor that lets it run these new components in Docker containers. And this video is showing all of these features. First, I'm going to start the development container's GNU Radio companion with my host's workspace attached. This container is based on Ubuntu 16.04 and has both GNU Radio and REDHAWK installed, which lets us work without having to install either one on the host system. You just need a fairly recent Linux distribution and Docker 17 or better to start developing this way. Within the container, your username is simply user, as you can see here as I navigate to my workspace. And here's a simple FMD-mod flow graph, which is straight off the building an FM radio receiver example in the GNU Radio wiki. Well, almost. The flow graph will be deployed as a component in REDHAWK, which means it will be deployed to a general purpose processor, GPP, and that means no display, no speakers. It's just a processor. So what's missing from this example flow graph are blocks like a usurp or an audio sync. You also don't see any Qt GUI elements, like plots. Instead, where we want to get data in and out, you see REDHAWK source and sync blocks. In this case, their IDs are complex in and audio out, which will become the REDHAWK port names. So if I could stress this just a bit more, this flow graph is now only dependent on signal characteristics, not a specific receiver. This helps with the portability and reuse of the algorithm, so now you can hand those signal characteristics to REDHAWK, and it will find you a receiver able to give you that data. The variables are also there from the example. Our tooling will try to infer the type of the variable for you, as well as only collect those variables where the value is actually set. Basically, those that are actually controlling things become properties in REDHAWK. Now we need to create our REDHAWK component for this flow graph. I'm going to leave the container running and use our convert script to run the converter within the container. This means any path arguments are relative to the user's workspace within the container. You also have the option to just simply run the converter without spinning up the UI. So here, just convert fmd-mod grc, and I'm adding a flag for the Docker image. This will generate the component that is compatible with the Docker-aware GPP, which means this component will be able to execute within a container environment like this one, even in the standard REDHAWK domain. In my setup, the host is a standard CentOS 7 REDHAWK installation with a modified Docker-aware GPP installed, and my workspace, where the component was built, is on the desktop. Installing this component to this local domain is simply build sh install, just like any other component. Remember though, it also requires a runtime container for Docker-aware deployment to be installed at the Docker-aware GPP. So we also run build image sh. Over in the REDHAWK IDE, we can now add the component to a waveform and run it in our domain. I create a waveform project and select our FMD-mod component. Save and drag the project to the target SDR to install it in the domain. And now, launch it set to auto start. Done. Our flow graph is now running as a REDHAWK component. And if we check Docker, we see the components container is up too. So now we just need data. I have an RTL connected to this domain. So we just need to allocate it with our flow graph's required signal parameters. For the center frequency, I've chosen 103.5 MHz, which is a talk radio station out here. Here's a plot of the data coming off the RTL. We can see our FM station. And for the sake of it, I'm going to select the allocation and then increase the gain. Now we can right-click this allocation and connect its float port to our flow graph. Select the float port and then navigate down to our running component and select its complex in port. Now, right-click the audio out port and play it.
Falling this morning, now 63 at Dulles Airport, BWI Marshall at 66.
9:10 now, and President Trump is challenged.
We've demodulated FM radio using a GNURadio Flow Graph, deployed in a REDHAWK component, which is executing within its own container environment thanks to Docker. Now, you're probably thinking at this point, but that's exactly what I can do in GNURadio as it is. Well, yes and no. If you wanted to use this flow graph to work with a usurp and an RTL, you'd end up with two copies of the same flow graph because you would need one with a UHD block and one with an RTL block. On the other hand, this flow graph does not depend on a specific receiver. It depends on signal characteristics. So, if we have another FEI compliant device connected to this domain that could meet these characteristics, we could keep launching and connecting more instances of this same waveform without modifying it, and each one would be fed by a completely different vendor of receiver. This is what we mean by hardware agnostic design, which is a powerful capability you can get basically for free by integrating your flow graph into REDHAWK using this toolkit. And before we close out this demo, it's important to point out that we just manually ran through the process that REDHAWK can actually automate for you using an FEI Tuner allocation embedded in the waveform. We cover how to do this in our waveform usage video linked in the video description. Then, anytime you launch the waveform, REDHAWK would automatically handle the allocation and connection for you. However, it's also important to point out, though, that it's also easy to do the exact same behavior from within a REDHAWK component or device, which would act like an application manager or tasker for your system. G uncovers that setup in an in-class training session. That's it for this demo, showing off our GNURadio REDHAWK integration package. We hope it enables you and your team to reuse all those flow graphs with only minor modifications in REDHAWK. If you'd like to participate in this project, please contact us or submit pull requests. This is Thomas with GN Technologies. Thanks again for watching.